Are you able to see my screen? Guys?
Yes, ma'am. Yes, ma'am.
Okay.
Able to see.
Fine, fine. Okay. So, today, good evening, everyone. Today is the live session 6. So, in last class, I have covered these Bhuvan thematic layers, the web map services, and OpenStreetMaps, and how Google satellite imagery you can bring in your QGIS, open source GIS software, and how you can do georeferencing, digitization, how you can calculate the area of the boundary, and how you prepare a map, like all the feature containing in a map. What are the things you can bring in your map? So these things I have covered in last class, that is most on the hands-on session. So today is the geo positioning system, global positioning system, and database management system I'm going to cover in this today's class. So guys, the global positioning system is the system. It is a network of satellite. In that you have number of satellites, around 24 satellites are there, which are receiving devices that used to determine the exact location of any object on the earth's surface. So to specify accurate navigation, so this is the plan or idea of United States Department of Defense, which came up with the something called Global Positioning System or GPS. This is a radio-based navigation system that gives 3D coverage of the Earth in 24 hours a day. So that provides time and 3D image, position, velocity information to the suitably equipped users anywhere on the or near the earth's surface. So to locate any object or any individual on the globe on the earth's surface in your GIS software, you need this global positioning system. So GPS receivers decide the position on the ground by receiving the signal from minimum 3 satellites. For any to access any receiver position, you need to have minimum 3 satellites. The principle on which this GPS is working is trilateral. It's called principle trilateral principle. So it does not measure angle, unlike triangulation. Because triangulation, you have to measure angle, you have to measure two more distances. But in trilateral, no need of angle measurement. It uses distance from multiple satellites, because minimum you need 3 satellites, and to decide on the coordinate of a point, because anything you need to go for point. As we did in georeferencing, what we did, we located four, minimum 3, it should be 4 point you should locate, then only you can reference georeference any imagery or any point or any raster or vector on the globe through your GIS software. So you need to locate the latitude and longitude of any individual or any object. Then only it will be located on your, then only you can perform any analysis in the GIS. So GPS work on the principle of trilateration. So please remember this. And GPS is having the combination of 24 satellites in 6 orbital plane. As sir has discussed in the class, there is on the globe there is a 6 orbital planes, 4 satellites in each planes. It means a 6 orbital plane and 4 satellite in each orbital plane, which means total 24 satellites are there, which is having the altitude of around 20,200 kilometers, the satellite's altitude. As you can see here in the mesh, how this satellites are moving around the globe in the orbit and 55 degree at the 55-degree inclination. So GPS having three segments: space segment, control segment, and user segment. See, space segment mostly comprise of the you can say the uh, combination of satellites in the space, and this is called space segment. And when the data is sensed or is taken or downloaded or uploaded, that is handled and manipulated by control segment, and these signals transfer to the users or to us or to anywhere on the globe for receiving or understanding these things. It's called user segment, where we are dealing with. So we'll describe the space segment, control segment, and user segment. The GPS segments, here you can see the combination of satellites are coming under space segment. This is the distribution. This is the different segment I have shown here. The user segment, where we are using, and the control segment, power stations, where things are getting in control, from where we are getting the received signal and we are using for our own purpose. So basically, the space segment is a collection of satellite or the space vehicles, you can say. Generally, the satellites are called space vehicle because it is moving into the space or orbits. The space segment consists of a nominal constellation of 24 operating satellites. As I have told, there are six orbit, four satellites in each orbit. So 24 operating satellites that transmit one-way signal that gives the current GPS satellite position and time. What the space segments are providing is the position and the time. And then the second segment is control segment. It is consist of worldwide monitor and control station that maintains the satellite in their proper orbits. So how it is, the control segment is kind of power station which is maintaining everything for the users, for the space segments also. So it consists of worldwide monitor and control stations that maintain the satellite in their proper orbit through occasional command maneuver and adjust the satellite clocks. So it tracks the GPS satellites and upload the updated navigational data. Means how which position, which angle it is currently. So it gives the information of the navigation of the satellites and maintain the health and status of the satellite constellations also. Like it take cares of the space segment satellites and it gives the information to the user segment through how it is navigating and what is the current situation, how is the health of this satellite, and means it is working or not, is it like moving or it is giving the information appropriately or not. So these are the working of control segment. Now, user segment consists of GPS receiver equipments, like which receives the signal from the GPS satellites and uses the transmitted information to calculate the user 3D positions and the time. As we need, okay, if I want to locate any point on the globe, so we need latitude and longitude. This is the GPS is the provider of all these things. From where we are getting this is space segment, the satellites are tracking these things. The control segment uploading this updated information, and the user segment using this information, transmitting for their own purpose, and making this 3D positions and time information for further calculation. So Earth's surface is divided into, as I told, six different orbital planes, each planes having four satellite vehicles, and there are total 24 satellites. So 24 satellites inclined at 55 degree at, and each of this orbital plane is at 60 degrees. So in space segments, it is spaced at 60 degree apart and inclined about around 55 degree to the equatorial plane. So keep in your mind. This is the important point. So ideal satellite geometry, how it should be. As sir has showed so many pictures, so there I have captured one picture and I was telling, I thought of speaking about this ideal satellite geometry, how it should be. See, we need minimum four satellites, three satellite. So we need four satellite to exactly locate with the velocity also, because when just we know latitude, longitude and the height and the time, we need three, but fourth will give more accurate measurement. That's why we generally speaks, okay, we need four satellite, each of these satellite signals giving four different measurements. What are the four different measurement? X, y, z and the velocity. The z is the time, X will give you the latitude and longitude, and the altitude, the height, The latitude longitude generally is in degree and minutes, and the height will be, it's having the precision of around 20 meter to 1 mm, and the z gives the time information, which is having the precision of around zero point 0.1 nanosecond, or you can say 10 to the power minus 10 seconds. And the velocity is taken care by the last fourth satellite, which will give you the accurate information or position of any object or individual over the globe. So that's why we need minimum four satellite to exactly locate the information of any object over the globe. So this is the ideal geometry of the satellite. It should be in such a manner. So GPS satellite signals, normally any of the space vehicle which are in space can transmit two microwave carriers. One is L1 frequency, another is L2 frequency. L1 frequency is around 1575.42 megahertz, and L2 frequency is around 1227.60 megahertz. See, the L1 frequency, it carries the navigation message, and the selective positioning services code signals. It is having this information with it. And then the L2 frequency, what it deals, it use this measurement to the ionospheric delay by the precise positioning services. So this two frequency used to be there in your space vehicle from the two microwave carrier signals, and one is carrying the carries the navigation messages, and another is to measure the delay or time for the precise positioning services or to the equipped receivers. So we are more interested in precise positioning, and from the selective positioning services we are getting this navigation message, and we are measuring through this L2 frequency thing. And the accuracy of precise positioning services, which is not generally available for local people who are like more into this, they are only getting this information, but for local public we are having this selective positioning services. The, the precise positioning services having the accuracy of 22 meter horizontally and 27.7 meter vertical, and it is having the time in 200 nanosecond, the accuracy of time measurement. And similarly the selective positioning services having the accuracy of 100 meter, generally 100 meter of horizontal and 156 meter vertical accuracy, and 340 nanosecond times accuracy of the selective positioning services. So this is available for general public, this signal. So one more thing sir has discussed, like wide area augmentation system, WAS. See, generally GPS having some accuracy, but to accurately for ships navigation or for any directional purpose where we need to know the precisely accurate direction to move forward or to do some specific work, we need to go for wide area augmentation system. It deals with the air navigation, like for flights, for aeroplanes, or for big ships to move forward, for warship, such kind of things. And air navigation at develop at it helps to develop by Federal Aviation Administration to augment the global positioning system. The goal of this is to improve its accuracy, integrity, and availability. So the advantage of WAS system, if you see in this figure, you can see how GPS accuracy is around 50 feet in general. And if you see here, the WAS accuracy is around 10 feet, which is around 3 meter approximately. So it gives the very precise exact location. It helps to improve the accuracy for the navigation purpose or for the directional indication. So it provides the accurate navigation signal, precision approach for airport at lower cost, and cost effective alternative to ground based system also. Okay.
Ma'am,
Yes.
sorry to interrupt.
Yeah.
Ma'am, is WAS is depends on GPS accuracy.
Yeah.
Suppose in our mobile phone, we have different GPS, and in naval or army system have WAS accuracy GPS system.
See, for general public, we have GPS. We need not to, if you zoom for 30 kilometer, if you like, when we have the resolution, if you see in your phone, somewhere you will be deviating from your path, like it is around 50 feet, what I told here, it may be around 15 meter or something, you won't configure in your mobile. But when you need to move the ships, when you need to move the flight or aeroplane, it should not deviate more na, from the path they have allocated, because it will be disastrous for the general public. So for navigation of ships and flights or such kind of things, where the directional information should be accurately measured or should be having some good availability, so that no accident or no any disaster will cause, so we need to be more precise. So those people will buy this, because this is the aid of Federal Aviation Administration to augment the positioning system. So this will give, this is not available for us, this kind of systems are available for those specific persons who are working in this domain. So you can't say like in our phone we are having this GPS, it will not, see, it will be helpful for us, because we are not, as we move our vehicle, 15 meter is how much, not that much, for, as per my knowledge. And if you see VAS is 3 meter accuracy, and it is giving the more precise information for the aviation or for the uh, ship navigation. So it is a bit different, you can say, for these people. This is, as I told, signals also, the precise positioning services are available for this specific people. But for general people, we are having selective positioning services, selective information, not exact or precise information. Did you understand between accuracy and precision, as sir discussed in previous class also? The precision
Yeah.
means how nearer with your exact value or exact location, but accuracy is somewhat approximate is also fine. Okay, so when we see in our GPS, we are somewhat approximate, okay, this is, this shop is nearby, or this location is nearby to this, so that much we will walk and go, or that much we can take any cab or any bus services and we can go. But for these kind of purposes, as I told you, for the aviation or for the ship navigation, such kind of things, we need to know the accurate lane or accurate directional movement. That's why these people used to have this navigation aid. Okay, so this is the air navigation ad, which is wide area augmentation system, that is not available for general public, that is for a specific people. So if you see here, two people have been captured in this imagery, if exact location, okay, nearby, this much near you are. But if you see in your GPS mobile phone, you can see, okay, you locate in such a manner, nearby you will appear. But if you zoom, so how you will see some deviation will be there, right? Did you understand the point, Malay?
Yes, yes,
Oh,
yes, ma'am.
okay. So this is the accuracy of GPS, this is the accuracy of VAS, which has been shown in this figure. So somewhat for the general public, the GPS is available, and for the specific people who are working in this domain of navigation or directional purposes, they mostly use this aid of VAS. So as sir has discussed, there are different sources which GPS is causing. In GPS, we, there may be error. As I have told, some deviations are there. So it can be user mistake, it can be satellite error. As I told, the control segment used to monitor the clock and timing of the vehicles, space vehicles. So that can be also an error. That can be error due to multi-directional scattering of this information also. So I will tell one by one what are the sources of GPS error. Incorrect datum, when it comes to user mistake account for most GPS error is generally if we put wrong latitude and longitude, incorrect datum or incorrect projection. As you saw in your imagery, if you do incorrect projection, you won't locate exactly the map on the globe, correct? So the datum should be correctly allocated. The typographic error which human can make. Okay, so typographic error. Maybe you are giving some 45.65, and you mistakenly have seen, like in your map you have seen around 48 or something, but the print is not proper. So you mistaken has mentioned this latitude or longitude in a wrong, like 43 or something. So this can be an error, typographic error. When inputting the coordinates into the GPS receiver can result the error up to many kilometer. Because see, small, I told you, okay, can anyone please tell 1 degree deviation is how many kilometer accounting for? Do you guys know? I have spoke in my previous classes. When I spoke about latitude and longitude. So 1 degree account for 111 kilometers. Okay. So you see, 1 degree is accounting 111 kilometers. So any small deviation will also cause the wrong positioning. So unknowingly relying on the less than four satellites. In general, we really need four satellites for exact locationing. So if you rely less than four satellites, okay, you say, okay, I have three satellite information, I will put into this and I will get. But no, you can't exactly locate. So this is also a source of error into this user mistake. And then for determining positioning of coordinate can also result in unreliable position and fixes that can easily be off by a distance in excess of miles. Like your unit should be fixed. It should be in mile, or it should be in kilometer, or it should be in meter. One unit, standard unit, you should follow. So even the human body can cause signal interference. So sometimes we are holding, GPS we used to hold, we used to locate. So GPS receiver close to the body can block some satellite signals and hinder the accurate positioning. So you should hold in a proper manner when you are locating any position on the GPS receiver has no way to identify the correcting user mistake. If you put if you input the wrong value itself, then whatever you process you move forward, it won't give you good. It won't give you the accurate measurement, and GPS also can't, because you are inputting these values into your GPS. Satellite clock errors are, like as I told, caused by slight discrepancy in each satellite. Four atomic clocks. Errors are monitored and corrected by master control station. As I told, the control station will be dealing with the clock setting of into the your space segment these things, as I have discussed in my control segment point. So it has to be maintained properly. Or orbit errors, like satellite orbits referred to as satellite ephemeris. So pertains to the altitude information, the position, speed of the satellite. So satellite orbit vary due to gravitational pull and solar pressure fluctuation. So orbit error are also monitored and corrected by the master control. Master control station will be dealing all the things which are connected to the your space segment, like clock information, positioning information, it is navigating properly or not, it is working health, and all the things of the space segment is dealt by the master control segment, and then it has been transmitted to the user segment. So it has been taken care. Orbit errors also should be taken care through the master control stations, by the master control station. Ionospheric interferences means we are having different layers of atmosphere on the globe, on the earth's surface. From 50 to 500 kilometer altitude we are having this ionosphere layer, so that consists primarily of ionized airs. This ionospheric interferences cause the GPS satellite radio signals to be refracted as they pass through the Earth atmosphere. As we know, the satellite is located as 20,200 kilometers above from the Earth's surface. So, in in this distance, or in at this altitude, you can see 50 to 500 kilometer we are having the ionospheric layer of the atmosphere. So when some radiations comes, it may refract, it won't give you the exact point. So that's why this can be an error to measure the exact location, causing the signal to slow down or speed up. Sometimes it may affect in terms of speeding up the signals quickly it comes, we are not able to capture, or slow down. So we are waiting and we are not getting the exact location. Sometimes it may cause. So this result is inaccurate positioning measurement. So this will cause inaccurate position measurement by the GPS receiver on the ground. Or next is the tropospheric interference. Like as I told, ionospheric, tropospheric also will come under it. So tropospheric layer is around below 13 kilometer. So that experience the changes in temperature, pressure, humidity, all related to the climate of the atmosphere. You can say like temperature, how the minimum and maximum temperature over the Earth's surface, the pressure of Earth, pressure of the air, humidity, these things can be taken care. The weather changes. The GPS errors are largely due to water vapor. So if the temperature is more, water will evaporate easily. So in this layer of the atmosphere, tropospheric interferences is fairly insignificant to GPS. This error cannot be corrected by the GPS receiver. So GPS receiver can't correct this such kind of error. Like as I told, user generated error, tropospheric error. So we have to take care of this sources of error, what we are able to handle. So some correction will be there for such error where we are not able to take care, or some mistake may happen. So for this some correction will be there when you get this information. Then multipath interference. What happened when this, if you see this figure, when the signals are coming from this space segment, it is getting interfered or reflected through the object on the Earth's surface. It caused by reflected radio signals from the surface near the GPS receiver that can either interfere with or be mistaken for the true signal that follows an uninterrupted path from the satellite. Okay, so multipath is difficult to detect and sometimes impossible for the user to avoid, because you don't know, you are standing, you're capturing the information, the positioning information. What happens, the signals are coming and it getting reflected from any object over the nearby to you, but you won't configure it easily. So it is like multipath is difficult to detect and sometimes impossible for the user to avoid also. You can't go and break the thing nearby. So you have to take care of these things when you collect. So some distance from you, like as the you can say accuracy of GPS is around 50 feet. So you will take care of this to collect this positioning information. So receiver, uh, for the receiver to correct. So common source of multipath includes car or bodies, buildings, power lines. It may reflect your signal or it may divert your signal, or the water bodies, such kind of things you have to take care when you collect this information. When using GPS in a vehicle, placing an external antenna on the roof of the vehicle will eliminate most signal interferences caused by the vehicle. Okay, vehicle here is talking about, like, if you have this signals, and what you do, you keep some antenna which will reflect, which are coming from this object, coming from the interference of this object, then you can take care of such kind of errors. So multipath interference you can take care of, you understood. Then
Yes,
then the number of
ma'am. Your
satellites.
skin is, ma'am, your skin is very short, ma'am. Can you enlarge your skin?
Okay, let me see. No, just wait, we'll check here.
Okay.
Just a minute. No, it's not. When I am going to presentation mode, it is not coming.
Yes. When you go to presentation, three people are coming and slide is short, left side.
Okay. So no letters will be like cutting down, right?
Okay.
No, I'm
No, no,
just
no.
no, no.
Total.
Letter should appear. I'm speaking all the sentences, so don't worry. You'll get the material also, no issue. So I was talking about this multipart interferences. Next time onwards, I will take care of this thing. So, okay, this time you please manage. So, number of satellites visible. This is also an error, like how many satellites your receiver can able to see for better accuracy. So, signal interception can be blocked by the building or terrain or electronic interference, and sometimes dense foliage are also there. Okay, so this clearer view to the receiver for the better for the better the reception. As the clearer you are getting the signal, you are able to catch the exact position. So that is the thing. Number of satellites are able to visible and helps you to capture the exact positioning. So satellite geometry, this refers to the relative positioning of the satellite at a given time. As I showed you, na, the imagery, the circle and this thing. So this will tells like how the satellite should be positioned to gives all four information which we are willing to get for any object information or for any individual information on the globe. So ideal satellite geometry exists when the satellites are located at wide angle relative to each other. Poor geometry exists when the satellites are located in a line or tight grouping. Means all satellites are grouped together. Means in one circle itself. It's not properly. So if it is a some wider distance or some at some good angle or positioning, it will capture more information. As we are interested in latitude, longitude, altitude, time, and velocity, so this information can be captured if satellites are properly spaced in between them. Then only they will capture more detailed information, but it shouldn't be that far also. There is having a precise distance or spacing, and it shouldn't group also, so that it can't give you more information. So spacing should be accurately maintained, then only we'll get. So this is means satellite geometry should be proper, then only you'll get the proper positioning or all four information, or else it is a poor geometry, we can say. Tight grouping can form poor geometry. So what is the differential GPS? Like when we talk about differential GPS means we are now accessing the real time information of anything. Like we are tracing the path, or we are tracing any vehicle is moving on the surface. Now we are interested in, okay, how much time it has took, from where to where it is moving, what is latitude and longitude it is covering. So like that, real time differential GPS employs second stationary GPS receiver at a precisely measured spot, usually established through traditional survey method. So how it has been came up with, some traditional surveying methodology has been used to get this differential GPS information. So the receivers, this receivers correct any error, so that, see, if we have this real time location information, we'll be able to correct a lot of, if previously stationary information we have, we may not know, okay, further how it has gone. But when we have differential GPS kind of things with us, so we can able to track the previous things also and the current things also. Okay, so like that it helps the receiver to correct any error found in the GPS signal if we have this differential GPS, and including atmospheric distortion also, orbital anomalies, selective availability when it is existed, and other errors also it has been, it is able to tackle. So a DGPS is station is able to do this because its computer is already known its precise location and can easily determine the amount of error provided by the GPS signal. The DGPS correct or reduces the effect of which one? Orbital error, satellite clock error, receiver clock error, atmospheric distortion, selective availability. Okay, so orbital errors means when it tracks the location, the navigation is proper, means no orbital error can be can harm or can uh, impact the data or the location what we are tracking. Or satellite clock error means this master or control segment is taking care of the exact timing, real time na? So and the receiver clock also means we are getting the information or we are tracking the information also, it has been accurately maintained. And then atmospheric distortion is any distortion caused by this atmosphere, troposphere, or you can say ionosphere layer, which I have discussed earlier, the sources of GPS error. So it can be, it is easily taken care through this DGPS. And the selective availability means the information has been properly maintained through this thing, as it is able to account for all this error and distortion. So the DGPS cannot correct for GPS receiver noise. The only problem with this thing is we have to take care of the receiver's noise, the in the user receiver, because some noise will be there from where we are collecting the signal user side. And multipath interferences means when we are collecting signal, we are standing in such a position where in between 50 feet distance itself you are having buildings, you are having another vehicles, cars, water body or something. So it can't help you to recover these things. This is user side mistake or receiver side mistake. So user receiver, it can't correct this errors. So multipath interferences and user mistake. In order for DGPS to work properly, both the user receiver and the DGPS station's receiver must be accessing the same satellite signal at the same time. You have to take care. That's why the receiver clock error and satellite clock error has been maintained properly. And then only you'll be able to track exact location, taking care of less or minimum error, because we are interested in getting the data, but somewhere users can make mistakes, somewhere what the space segment satellites or the things capturing and these things may having some errors. So to take care of all this discrepancy and distortion into your information what data you are collecting, so this DGPS is helping somewhat to reduce it. So this is having such kind of applicability, or you can say feature. Now, what is the global navigation satellite system? See, generally we have number of positioning system like GLONASS, Galileo, BEDU, Compass, QZSS, Indian this navigation satellite system, Navik or Gagan. So these things, which country have been developed, from where it came, sir has discussed in this class of global navigation satellite system. So the operating ranges we are interested in, like what can be helpful for our purpose when we need some data, which satellite or which system we can refer. So that's why operating ranges for each positioning system we should know. So okay, lunas have been developed by Russia, but it is operational to worldwide. So if we need some Indian data, we can get from that also if we have such kind of access. Galileo is also European Union and partner countries of the European Union. It is having operational to worldwide over the globe. Bidu is also Compass, and Bidu and Compass is of China's this satellite system, but it is having the information of Asia plus West Pacific. And then QZSS is came from Japan, and then now it is uh, operating range of Asia and Oceanic regions also. And IRNS is Indian generated Navik and Gagan, which are mostly focusing.
Ma'am,
Yes,
ma'am, sorry to interrupt. Ma'am, one thing I want to ask you,
yes.
like GLONASS and Galileo, its
Hmm.
range is operational worldwide. That means it have 24 satellites only.
Sorry, 24 second. What you are
Ma'am,
asking?
only suppose six orbits, okay,
Hmm.
ma'am,
Hmm.
and each of orbits for four satellites.
Hmm.
Satellite.
Hmm.
That means in Galileo
Hmm.
on four satellites
Hmm.
only. sorry, 24 satellites.
See, they have their own satellite system, yeah, over the globe. The thing is, they have sent this satellite vehicle, space vehicles. That's why these countries' name are coming in picture. But what they are doing, they are capturing the information. This positioning system is capturing all over the globe. You understood?
Capturing done by satellite. So minimum 24 they must set.
Ah,
They have set
they
it.
have to.
Minimum.
Nowadays, three more have been added, I guess, from last 3 years or
Okay.
4 years, 2018 onwards. You can say 27 satellite because for more information. See,
Okay.
when we need more finer information, we need to send because see some capability or some capacities are also there, no, with the satellite systems. So to handle worldwide data we are having, so these people, these countries have sent their own space vehicles in the orbit, and they are capturing the information over the globe, and they are providing. So that is the GLONASS and Galileo is doing. But other than that, the China, Japan and India, whatever we have established, we are sending our space vehicle, and minimum we need 4 satellites. So we are able to capture until this Indian satellite is able to capture until southern Asia. So that is the thing. The operational range. It can be, see, it gives the information until here, this area, you can say. Okay. So the
Okay.
satellite having the capacity of this much range. After that, it is not able to send the signal to the control segment or to the power station. Then only receiver or we people or user segment will get the information, will transmit it, will convert into our own data, and will use it. The latitude, longitude information and these things. So this is the meaning of this navigation system. Navigation means movement, movement of anything over the Earth's surface. Some satellites having good capture capability. Russia is the developed country. European Union, most partnership country, they are having good satellite capacity and they are sending such a space vehicle and they are getting operational worldwide information with themselves. There maybe some open source will be there where we can get the data of our own space, but India is working on our southern Asia part, and they are having the Navik and IR, NSS, Gagan, these things. So we are dealing with the southern Asia ranges. So that is the thing. If we develop some more capacity space vehicle, more range, more capturing capability of the space vehicle, as we used to launch, you may know, new satellites are getting to launch with more capability, है ना, compact sizes to capture more information. So these things will be there with the navigation information. So these things are developing. If you see per year or after 5 years, you can see this news is used to come. This will give you some good information. So how in lab or how the people are working with the GPS satellite system, and then getting the information, what are the information, what are the corrections should be applied, and then with this information what inferences you can get for your own working. Okay, so you have to know which is satellite, what is the range, what information are available into that, as we are capturing information from, you can say, Google Earth Pro, or yeah, Bhuvan also giving some information, having some cartosat satellite and this Landsat and these things. I have spoke in my previous classes what is the resolution of this thing. That are another thing for this thing, but for positioning information, these things, for accurate locationing, these things are, then only you'll be able to take this information into your GIS to get some inferences. So this will be basic things, or are the fundamental things should be there. Then only you'll be able to work with this GIS. And then what is this IRNSS? So it is an automation of regional satellite navigation system of India that provides accurate real-time positioning and the timing services, and it covers India and a region extend around 1500 kilometer around the India. If you see here, satellites are there, space vehicles, and this is the Indian regional navigation satellite system. which is having some extent of around 1500 kilometer. It consists of 7 satellites. Three of the 7 satellites are located in the geostationary orbit, and remaining 4 satellites is inclined geosynchronous orbit. So geosynchronous geostationary orbits are there. So in that, geostationary means the satellites are stationary on the orbit and they are capturing some information. So from the 7, 3 are on the stationary position and remaining 4 are moving with the orbit. So 4 are taking the information. Okay. So as you asked, it's like minimum 4 should be there. As per the country's capability, they are sending the space vehicle and they are capturing with as per their own way. So this is the thing. Okay. So the application of GPS global positioning system are like it provides the geodetic control points. It provides the survey control, photogrammetric control, surveys and mapping. As we know, we are going to use in my map in mapping and locationing. Finding out the location of offshore drilling. What is happening? As you see, army people, navigation people, navy people, these people used to get the information when we like take off and landing. We get to know, okay, these are the climate or weather condition, these are the nearby. They used to check all the information. How they are getting? From the GPS only. So finding out the location of offshore drilling, what are happening. If you see the border areas, generally they used to send such kind of satellites to get the information. What is happening? You might have seen in some movies also, they used to, in army people and navy people, how they are getting the signal information and getting the information. Okay, this is the danger area, this is the safe area, okay, there we can move. So for ship, for aeroplanes, these things are very very important thing. And the drilling and the pipeline or power line surveys also have been done through the GPS. You can say navigation of civilian ships and planes, as I told. The the crucial measurement studies and geophysical positioning, mineral exploration and mining, the determination of a precise geoid using GPS data. Did you understand this thing? Determination of precise geoid using GPS data. How precisely you are able to capture the information of anything on the globe, or it is a moving object, or it is a stationary object. Moving object like car, any vehicle or something, or stationary object like any monument, any building, anything which has been built. And then estimating the gravity anomalies also. These satellite vehicles are very helpful to get the information regarding the what is happening, like how the climate is changing, how the this ionospheric layer, as I told, interferences, and the tropospheric interferences, how these things are affecting the earth environment. This can be also captured because it's sending the signals. Some user segments, control segment, these signals have been received by the user, and they can get some inferences in terms of climate information, in terms of weather, or in terms of urban information, how much things are changing, how high, how you can say how the urban improvement is happening on the globe, how the climate change is affecting the CO2 level, this ozone. These things can be taken care because it is this satellite or this space vehicle are very, like, it is in orbital planes, so it can capture a lot of information, but that is also having some error with it. So we need to know what, as per our own interest, which data we are interested in, what corrections should be applied. If we are having such a satellite data, we should know about the satellite information, what are the capability of the satellite, what kind of signal it is sending to the receiver, what receiver correction should be applied to get a particular data set for our own use or purposes. So that thing. And anomalies means gravity anomalies, any water movement, as I told, it is susceptible to water movements on any, like, fluid movements or land, any vehicle movement. These are capturing mass movement, you can say. with the gravity. So it is capturing that signals also. So in the estimation of that gravity anomalies, it is helpful. Offshore positioning, shipping, offshore platforms, fishing boats, these things are also, this GPS is very much applicable. You can say GPS is really applicable for not only like our general people nowadays. Wherever we are going, if we are not knowing, we are just navigating, or we are just opening the Google Maps. How this information are allocated there from survey, from all this latitude and longitude has been covered through what? Through these satellite vehicles having the control station. These control stations are providing all the navigation information. And then it depends for general public how general the information should be. For specific or for such people, the information should be go precisely. So they use their own VAS, their own such specific vehicles information, from where they get the precise location or data to work further. So for us, what is the needed? It is available, and people are working on more precise information. So this is the thing. Offshore positioning, shipping, as I told. So these things are the application of global positioning system. So now we'll move on database. See, generally, whatever till now, whatever we did, we collected the
Ma'am,
data.
madam,
Yeah, yeah,
uh, ma'am, I have one question. Like GPS has you told GPS has many errors,
yeah.
but how in DGPS you told that there will be a stationary rover
Hmm.
along with along with one GPS. So how it will correct like errors, orbital errors, satellite clock errors?
See,
What is that particular system? How it is able to correct, ma'am?
see, DGPS means this is tracking the real time information. So the thing is, if we are having stationary GPS receiver, so okay, one time information you will be getting, right? Another time information for another object you will be getting. But when you track a vehicle, when you track any object on the globe, you'll be tracking how it is moving, what time it is reaching there, and there will be receiver corrects the errors found in the, if you see my this third line, that this receivers correct any error found in the GPS signals, because it is tracking. When you track anything, so you'll be able to understand, okay, these things can be taken care of. But when you have one point information, another point information, you're not knowing in between what is happening, what signal might have diverted, or what object may occur some reflection or some signal deviation, you don't know. So the thing is, it is helping to reduce the error in terms of this time clock management of satellite or receiver clock management, because it is having a powerful control segment, you can say. Okay, it is
Yeah,
differentiating when
if I
you.
understood,
Hmm,
for example, I want to know the
hmm,
location of a particular point. So
okay,
using GPS, so at one time I will take the latitude and longitude, but it may contain many number of errors at one. matlab at a time I can
okay,
take. I can say
okay,
at means 10 o'clock I have taken the
huh,
location,
okay,
but in DGPS you are saying that 10 o'clock we will set up the system like one
yeah,
stationary GPS and long time we will track it.
yeah.
So after a long time we will get certain kind of error which user has to correct, and then we will get the correct location, something like that one.
See, yeah, you can say this is also, but the thing is, the including the atmospheric distortion, the orbital anomalies, or selective availability, when it existed, other errors also. It means when you track something, you will understand, okay, this thing is happening in between. But when you having a stationary data, you don't know in between if something is lax also or something is not available. Then you will you'll be not knowing at one point to second point, why, okay, this error has came. You understood my point? What happens when you track some information? It will be capturing just before this, it might have happened. Okay. But when you have far distance 2 point, you can say information, you don't know in between what is available. Okay, you are having this 2 point information. In between, some orbital error may cause, some satellite time clock not has properly set, or receiver time clock has been missed. So DGPS can't correct the GPS receiver noise from user receivers, I told. Like multipath interference, you understand what is multipath interference? This is user side. But what are the information coming from the space vehicle, we are able to track. That is the only thing with DGPS. Am I clear to you? Hello, Malay, are you there? So the a DGPS station is able to do this because its computer is already knows its precise location. The thing with this is good control station, or this computer where the data is getting received or getting uploaded, it has the precise location. That is only the thing with DGPS. It tracking each and every second or minute information, you can say, and can easily determine the amount of error provided by the GPS signals. The DGPS correct and reduces the effect of this orbital error, satellite clock error, receiver error, because it has been taken care through the precise location. You see, the main point here is how our computer knows, this control station knows the precise location. That's what is the main point in DGPS, which is not available in the GPS, stationary GPS. My first line itself is telling the real time differential GPS employs a second stationary GPS receiver at a precisely measured spot, usually established through the traditional survey method. Okay, so more precise information you are getting. That's why we are correcting some error associated with the GPS. Malay, are you getting my point?
Yes, ma'am.
Am I able to clear your doubt?
Yes.
If not, you can ask. I am not understanding what doubt.
Okay, ma'am. If doubt, I will ask.
Okay, sure. So this navigation system, these things I have told, IRNS also I have told, application of GPS. Then now we are moving to the chapter of database. Till now we are knowing how to collect data, from where we will get data, how is the data is, how we capture the data. In between I have told about this hands-on also in GIS, how you perform also. But when you have lot of data in your hand, how you will be going to manage this data in your system? How you'll be going to work with this data in a proper manner where you'll get good insights, good information, which can give you some output, some maps, some proper, you can say, database things. So there we need some database management. So the database management is the, like, we have different sources of data. You can say we are having some sentinel data, we are having some landsat data, we are having some USGS data. Okay, USGS, from there we'll get all this information. We are having from Bhuvan website some data. So different sources of data is available. How we correlate all the data, these all the raw data, how we'll get some information as per our own need, and how we'll convert or process this data and come up with the some results or output or some inferences. So this is called the database management. So the data is the collection of a series of fact, can be either sorted or processed or even recorded. For example, raw fact, list of numbers, contextuals. So these things are the data. So raw information, you can say. Raw, you don't know anything from that. This is the roughly you collected. Now you want to get some inferences. First you will, what you will do, you'll organize as per the things are available into the data. So how you'll organize? When the data gets organized and processed for our own purpose, like, see, we collected data from DYGIS for some population density mapping, or some road map information, for some land use, land cover, or water body information. So these are the raw data. Now you are interested in Indian region only. Okay. From Asia Pacific, you are interested in Indian region. Now you'll organize the data for the Indian subcontinent. And then you'll collect, okay, these are the road information. These are the length of the road. These many of national highways, state highways, village road, these things. Some are the water body information. These are the river basin. These are the lakes. Okay. And then some agriculture information, or some population. Okay, these many people are having, number of people are having in this region, urban area or rural area, or these many industries are there. Okay, when you organize these details into a sheet or into a column with, okay, all the information in a proper manner, then it's converted or become what? Information. Now you'll be able to, if you show someone this data, okay, that, if I show you, okay, I organize these things and I show, then you quickly understand, okay, this means these many people are having residence into the urban area, this many percentage of people, you can get some inferences, some information from that. So when you organize the raw data, raw fact, list of numbers, you'll be able to get some information. This is called information. When you processed it, arranged it, the data is raw thing, unorganized fact that needs to be processed. When the data is processed and organized, structured, or presented in a given context as to make it useful, it's called information. Okay, so the information is where anyone, if you show me or if you show any of your friend, okay, they will understand these are the things are available. That is organized form of data, which is information for some specific purpose. What is the database? Database means these collected things have been stored somewhere. You're storing in Excel sheet. Now you can, this Excel sheet you kept in a folder, so that is called a, like, physical record or some computer system record. So it's called database. Roughly I'm just talking. So if it is organized collection of data stored and accessed from computer system, a database can also be an physical record, like people used to keep in registers. Okay, this is the name of the, in any medical, if you go medical store or any hospital, they will make a register. They'll make a register entry. Okay, you, the particular name, who came, for what purpose this person came, for which doctor they are going to refer, what time to what time the appointment it is, what prescription they have made. So they will have a proper register. It can be a physical record or it can be a computer record, like soft copy, like we can make in our Excel sheet or in our own, uh, like any record of word file or something. So like that people can make record. That's called database, where we can store the information. This organized information can be stored in your computer system or in physical record. What is the database management system? Till now, raw thing is the data, organized thing is the information. These things can be stored somewhere, that is called database, where we have all these things. And management system can be added into this when this can be applied to manipulate some information. Means the database management system is a computer application that helps to create, retrieve, analyze, sort, and print information from a database. Like, this application can help you to create it, to make some changes. You can you can make any manipulation, like you can edit the information. See, like, if you are taking like if someone wants to know about this database, so, but everyone can't access this hospital, as I have given the example of hospital register record. So you are only able to give your own name or what purpose you came and all this thing. But if third person will come and say to see the record, they'll be able to just to see the record. They won't be able to modify. This can be with the management people only who are managing this information. So that is a general example I have given. So likewise in computer system also, when we manipulate this information, it comes under database management system, a computer application that helps to create, to make the changes, retrieve, to save the changes, analyze, to create some more sheets or tables or short, so that you short, okay, this many number of people or this many age group of people came, and then print the information. When you are able to manipulate the information, then only it's called database management system from a database. That's it. And then, what are the components of database management system? See, database management system having a database engine, where retrieving, storing, updating of the data means you can edit, you can do anything. So that is called database engine. When it comes to data dictionary, it describes the type of data and being that are being stored, and the data being stored in a particular database. This is called dictionary. Like, you have all the information into this file. So like that, it's called dictionary. The query processor, where users and developers to store and retrieve the data. Now you went to the dictionary and you opened, and you want to store some more data and take some more information. So users and developers to store and retrieve the data. It is both storing and retrieving. All these database operations can run through a query language, like all these things in computer. You are having sequential query language, my sequential query language. Very well known query languages is the my this SQL. So these are the processes in a database management system that can be handled through the IT systems, like information technology people. You generally used to use this database management because they are working with lot of they are storing and retrieving lot of information, and they are working with this kind of component. So they are having their own database engine, they are having their own data dictionary where they are storing the data, they are having one query processor where they are making the changes through coding or through sequential languages. Generally nowadays, well-known query languages, my query language, they are using for easy operation, for developing or for storing. And report and write. This is another component of database management system where you'll generate the report, whatever data you have. Form generator, it is an input screen that helps the developer to create form. And then application generator, where application purposes you can use generators, and communication and integration generators, and securities. So security means you have to take care of all the information whatever you are handling. You can't, you have to pin, give a pin or something where it can be secure, it can have some security or privacy, you can say. So like that, the IT system generally have such kind of info. Not only IT system, nowadays in any information technology people or companies or industry, they are having their own database engine where they are having past information, current information, the dictionary where they are keeping this information, storing this database, and query processor where this data can be manipulated, coding, and this language writing and these things. And from where we are generating this information is the report writer, and form generator, where you need to develop any form from the data set, and from where you have to utilize it comes under application generator. And when you have to communicate this data to the general people or to the any third person, how the communication and integration component will work, that is also a component of database management system. And it should have the privacy and the security. Whatever data you have, it can't be easily accessible to the unknown people also, you have to take care of. So these are the components of database management system. What is the data model in the database management system? The data model is the collection of conceptual tools for describing data, and what is the data, what are the relationship with another data sets, what are the semantic or uses, and consistency constraints are also there. Like for example, we have MS Access. Microsoft Access can deal with lot of data, with the qualitative data and quantitative data. Okay, quantitative data are in numbers, qualitative data are in text format, ranges, these things. So this MS Access are very helpful to manage such kind of database management. This is one of the example of database model. So to collect the conceptual tool, to correlate the data with another data sets, like if I want to deal with you can say I am interested in any urban land understanding, or any uh, okay, one city is there where I want to know lot of information regarding how the pumping is happening, how the are the soil characteristic, how are the number of people are in domestic area or industrial area, what are the water sources are available nearby, how the pipelines have been located, what are the electric power systems are there, stations are there, and how the electricity have been provided to the city, how it has been used. So we have kept all the information for a city for their uses, for different purposes. Then we want to correlate, we want to get some information. See, electrical people wants to know how the power stations, power lines have been distributed to the general residential people, or to the industrial people, or to the you can say commercial people or hospitals or such kind of things. And then other land source management people or water source people, they will see how the pipelines have been designed. But they should have all the data sets in a file or in a dictionary to correlate each information with each other, because one sheet is having your all population information, another sheet is having the water distribution network, another sheet is having the electricity pipeline network, another sheet is having the soil type or the things. And then so this dictionary having different types of information, and with the qualitative information or quantitative information, and how the people who need such information inferring this data sets and correlating this data sets, and understanding, getting some use how it can be used, and what are the consistency and constraints associated also, means how reliable the data is. And okay, until here we can think of a later, for far distance we can't rely on this data, we need another station information in such a manner also, then only we can infer something, we can come up with some output or some results. So these kind of models like MS Access helpful in this database management system. There are two kind of languages in database management system: the data definition language and the data manipulation language. The data definition language, it specifies data schema by a set of definitions. Okay, where all the definitions carries. So these are the data definition languages. When we are able to use and manipulate such data, retrieval, storing, retrieval, manipulation, deletion, editing can be taken care through human quantification and providing the qualitative information. All of this data can be manipulated, it comes under data manipulation language. And these are two kinds, which specifies the data definition language specifies the dataset schema by a set of definition, and where we can manipulate, we can retrieve, we can delete, we can edit the information through human quantification, or providing the qualitative information, it comes under data manipulation language. The database having keys. The key is the relation or combination of columns whose value uniquely identify each tuple. Tuple means rows. Okay. So keys,
Ma'am,
yeah.
you in data model is a collection of conceptual tools. So can you give example of conceptual tools? Some example of conceptual tools. Ma'am.
See, as I told, data can be qualitative or can be quantitative. So we need to have you seen how the MS Access, have you seen this MS Access software? In that,
Ma'am, I have used like SQL. I have used, ma'am. So
okay, okay.
so so like conceptual tools means what, ma'am?
Where,
Joining the tables, the
where you
tables.
can, one table you have, one sheet you have, you can relate this sheet values. See, you will give some customer ID, as sir has discussed one example in class. You'll give some customer ID or numbers, and the same number for another detail or another data. Okay, this customer have, say this residential area is there, so this name, if your home is named as per your father information or something, any elder people information, this elder people is paying the bill of electricity also, so this customer ID will be associated there also, and this customer ID is paying the bill of water uses also, this customer ID is paying the bill of the home rent also. So number of sheets have been associated with the same customer ID. How it can be correlated, you understood? So these tools in one database management system or one software is having, it's called conceptualization. Okay. The collection of conceptual tools describing the data, the information, and the relationship. Okay, this ID is only dealing with all these three things or four things. And the uses, the consistency and constraint. So when you open these things na, when you deal with one information of one sheets and same things with the another information for the same IDs, you'll be able to understand what is the meaning of concept. You can perform any mathematic operation, you can perform, you can make a plot of okay, this information for this customer ID is until here, for the same customer ID if we see another purpose also, another uses also, what is the thing it is using. Okay,
Okay, okay, madam.
so some conceptual thing means some mathematical operation, some plots, or you can say some figures you are able to infer from these sheets. So that is
Okay,
the information you'll be able to get from the database management model. Just see once in Google, like for your information, I'm generally saying, when you open, you just see once how the MS Access having the detailed information, how it is correlating one sheet to another sheet. Not only MS Access, other softwares are also there. I just gave one example here. What are the database model, and which are having the conceptual tools. Conceptual tools means all mathematical operation, all understanding plots, graphs, 3D. Uh, you can understand the charts and things with this. They can get some inference. So that is the meaning of database model, and how it is working with, how this is working with some database languages which specify the definition, the name of the property, or where we can manipulate this information also. The database keys are, a relation is any combination of column whose value uniquely identify each tuple in the relation. So key are the relation from one side, as I told, like customer ID or this thing. Primary key is the main source. Number of IDs are there, but who is the main? Like in your home, you are having number of people, but who is the elder person on that name? Things are allocating. So primary key is a key in a relational database. They're unique for each record, which can't be changed. As I told, your father is going to pay the bill of electricity, rent bill, and water supply bill. So these things having a unique customer ID. Another home, another elder person is taking care of all these things. So different customer IDs are there, so unique for each record, it can't be common. So in the relational model of the database, a primary key is a specific choice of a minimal set of attributes that uniquely specify the tuple in a relation. Without example, these things can't be understood properly, I guess. That's why this is just the definition. But you understand this definition, you need to know some examples of this primary key. Sir has explained in a better way in class, I guess. I'm just telling about the definition here. And one more key is there, uh, foreign key, where the things are coming from third party or out person. So that is getting some information or relational information in the database. That's called foreign key. And then type of database management system. There are five type of database management system: hierarchical database management system, relational, network database management system, object oriented, and object relational. So here I'm just telling relational database management system have been widely used for different purposes nowadays. 95% of database management system are relational. No people are going to work with this thing because relational is covering so many things into it. That's why relational database management system is widely used in several applications, including desktop, server based, cloud based application, where we are keeping our information on the online and we are taking care of all the things through relational database. Means we are correlating with the cloud based system, server based system, or desktop based system. As I connected, see, generally you may know in any IT sector all systems are connected, interconnected. So these are relational with some relation you may find this, uh, in terms of information or in terms of working I am talking about. Okay, so most popular type of database management system is this relational. 95% of the data is in database management system is using the relational database management system. For example, IBM DB2, Microsoft Access, Oracle. Generally, if for easier understanding, I am just saying you go through once about this Microsoft Access. So Informix. So these are the relational database management system examples. Okay. Something came, I guess. Okay. Now, what is object oriented database management system? Because it has been asked in your problem. That's why I'm discussing about this. So, object oriented database management system having some component into it like encapsulation, inheritance, late binding, and identity. So, what are the components are of the object oriented? Object oriented means now we are focused on a particular object. Like when you can say item industry, or like for any biscuit industry, or for any parley biscuit, or for any object, for any medicine industry. So that is that are object based, object oriented database management. So what happens, they're having some components of managing the database like encapsulation. Encapsulation refers to the bundling of data with method that operate on that, sorry, on that data, or restricting of direct access to some of the objects or component. It means what happens, we are bundling an information into a inside a like like we are keeping one sheet in which we are giving all the information, but we are keeping some security, or it is restricted to directly access of some objects, of an object component, like other than the our people or the industry people, no one get the information of the database. So we'll keep some security. or some bundling or some covering. That is called encapsulation, hiding. Okay, like that. Or inheritance means is a mechanism of basing an object or class upon another object or class, retaining similar implementation. Inheritance means okay, correlation with the other things. It's a mechanism of basing one object or class upon another object class. How can I say? Inheritance means same relation. Okay, this showing same impact. Uh, another product of the same industry is showing the same. Uh, uh, you can say same customer interest, or you can say the inheritance basing object, basing an object or a class upon another object or a class, retaining similar implementation, like same material or same uh, quantity of product or raw material have been used for one product of the industry, and same ingredients will be there for another product, but some modification will be there, but inheritance will be same. Like for one family, uh, for one parent there are 2 3 kids, so inheritance means similarity. Okay, it can be basically both are similar. You understood? Okay, so inheritance meaning base will be same. The late binding means is a computer programming mechanism in which the method being called upon an object or function being called with argument is looked up by name or runtime. Like what we are going to do, we are allocating a name, not we are giving a name or a function of the object for the given specific time. So computer programming mechanism in which the method being called upon an object or a function being called with an argument is looked up by name at runtime. And then this is called late binding. And then an identity is the column, is a column in a database table that is made up of value generated by database. Means okay, this is the identity, means this value is coming from this result. So this is the identity of the information, like this is the mean value or this is the standard deviation, like that. From the given column or from the given database table, we are coming up okay, this much average price will be there for the item, or this much raw material have been used for that item. So quantity, I'm talking in terms of quantity. So column, an identity column is a column in a database table that is made up of value generated by the database. Okay. So these are the object oriented database where we are more interested towards a particular object to understand and how to manage a particular object database. It can be any industrial product, it can be uh, any objective or any project or something where we hide the information. It's called encapsulation. Where some basic information match with another object also or class, it's called inheritance. When there is a function or argument looked up for the given time period with this programming, computer programming mechanism, it's called late binding. And when some value is for this database, the column giving a particular value, it's called an identity of the object oriented database management system. So mostly we are not into this, we are more towards the relational database management system. So I will suggest you just once go through with this Microsoft Access database model. What is the normalization? See, in general, we are having lot of raw data with us, but we don't know how to get the information. Then When the raw data is having for large long year long period or large information will be there, then we need to normalize that information to get some relational information. So how we are the normalizing or lowering the norm into the normal form of the database from using the database model, it's called to access or speed up. Like if we have large or long time period data, will take a lot of time to work upon this. So first what we will do, the raw data can be normalized. The data analysis method, it's called a data analysis method used during the design stage of relational data. So relational data, so that has relationship entity that has modeling which allows to reduce storage space data redundancy. Means when you normalize the data, okay, you are having a particular district, number of population, okay, this age means 20, you're having 10 to 20 year age, this many people, 20 to 50 year age, this many people, 50 to under 100, this many people are coming. So you want to like that, you are having number of district, number of first taluk, then you are having number of district, then you are having number of states in India. So now I want to normalize this data because we are having very like village level data, and we are not able to get some inference. We are having large amount of long years and like different columns. So to understand for, okay, now what I will do, I will just normalize it. How I will normalize, okay, 10 to 20 year age, these many people, average number of people or average number of people age is around, you can say, uh, 10,000 or something. Likewise, okay, this many, we will do some mean, some deviation. We can say, okay, plus minus 10 to 20% can be added or can be removed, like in a given coming years. So like that we can get some info. So what we will do first, whatever the longer time period data we have, we normalize the data. How will normalize? We analyze. This is normalization is the analyzing method during which the relational data has the relationship entity. I am correlating the age only for the population, and then modeling which allows to reduce the storage space. Then if I allocate, okay, for this particular district, for this age, this much the age, for this particular district up to this much the number of people. So like that for each district I'm able to, so one value I'm able to get from the particular district. I also correlate, and then I'll get one mean value. And for a particular a number of district will get, and then for a particular state, so we reduced the information or the memory of the information, we short it out. It's called the shorting or normalizing. Getting some relational information, we are what we are analyzing or we are manipulating the data, you can say, which allows to reduce the storage space, data redundancy. If the number are common or same, as sir has given one example, one customer is going to buy one milk packet, one biscuit packet, same customer is going to buy another snacks packet or something else. So we are having same customer ID in a column. So what I will do, I will merge these two things. I will say, okay, this customer have bought milk packet, this biscuit packet, and this snack item also all together. So what we are doing, we are compressing the data in such a manner where our data can't be like inconsistent, and it is giving a good information with a shorter space, like shorter memory, or it can't take large data memory. So ease of to maintain this data, because if common things are there, same id, same number of rows will be more. So like that we short the data. Okay, a technique to move from higher to lower normal form of database modeling in order to speed up database access called normalization. This is very important thing you should know when you deal with a large amount of data actually. So normalization procedure have been applied in all the database management system when we are going to deal with large amount of database. Database normalization is nothing but organizing the tables, columns of the tables in such a way that it should reduce the data redundancy and complexity of the data and improve the integrity of data. Means, okay, things will be unique id, unique information for each column or for each row for each customer, for a particular individual or items. It can't be correlate, or it is not common thing. So it reduces my space size also, and it gives a proper information for a particular thing. So that's called normalization, the maintenance of the database. So this is a kind of analysis of the data or modeling, you can say. So for today's class, guys, that's it. As per the problem statements, I have made my class today. If you get any doubt, you can mail me. The slides will be available for you people. Okay.